All right, these last set of questions are the free response questions, and these, again, have come from previously released AP tests. So it's not the free response question in its entirety, but it is pieces of the free response questions that you already know how to answer. So we will pull up the ones, or the parts, I should say, that you already know how to answer. Now, both of these free response questions came from number 2, I believe, of the free response section, and number 2 is a calculator required section. Numbers 1 and 2 are calculator required. Numbers 3, 4, 5, and 6 are non-calculator. So both of these we will be able to use a calculator for. Again, I do not have my graphing calculator with me, so you guys are going to have to follow along with yours as I do it on Desmos to show us how to get an answer. And again, I'll try to talk you guys through what you need to do on your calculator as we go through. So this is number 2 from the 2016 AP exam. It says, for t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by that function. The particle is at position x equals 2 at time t equals 4. Now, as we're reading through this, I will just tell you that that last sentence, the particle is at position x equals 2 at time t equals 4, will be applicable second semester, but it is not applicable yet. So you don't actually need to worry about that sentence because you're not aware of it yet, but we don't have any purpose for it yet until we get into second semester and we start going backwards with integrals. Because right now we have information about the velocity function, and next semester we'll be asked to go back to the position function where this will be important. We'll call that an initial condition, but it's not important quite yet. Part A, at time t equals 4 is the particle speeding up or slowing down? So remember, to figure out if a particle is speeding up or slowing down, we need to know two things. We need to know what the velocity is at t equals 4, and we need to know what the acceleration is at t equals 4, and we're going to compare the two signs. Now, I will show you everything you would need in order to get full credit for this question, because this is no longer multiple choice. You don't just get to do whatever work you want and then decide what answer choice it is from A, B, C, D, E. Instead, you have to prove to the reader that you actually know what you're talking about, which means you have to offer a proper justification, and I would like to teach you how to offer a proper justification for this problem. So first things first, we're going to take this v of t function, and in your graphing calculator, I want you to enter that in for y1 as I enter it in on Desmos. So we have 1 plus 2, delete this, I'll call it f of x again. 1 plus 2 sine of t squared over 2. T squared over 2. Oops, I always do that. Let's put an x. X squared over 2. Alright, beautiful. And this is what it looks like. So, this is the velocity function. I know I'm currently calling it f of x, but I want you to know that f of x is the velocity function because that's what I'm entering in. So I need to know what the velocity is at 4. So the velocity at 4, on my calculator, I can just put an f of 4. On your calculator, you would not just put an f of 4. You can do it a couple different ways. So you could go to the graph and push trace and type in 4. And that will tell you what the y value is at 4. It should give you 2.978, or if you're going to round it, 2.979. Or if you stay on the main screen, you can just recall the y1 function. So remember to recall the y1 function, you push alpha, the green alpha button, and then F4. Alpha F4 recalls all the different functions, and you can put y1. It will recall the y1 function for you. And then right after it, so your screen is going to look like this. I know you don't see it in front of you, but on your home screen, you're going to recall the y1 function. So you'll push alpha F4, and then recall y1, and then put parentheses around it and insert a 4 into those parentheses, and then push enter, and it should give you an answer that looks like this, 2.979 or 2.978. So that's another way to get what 4 is equal to. So from the home screen you can do it, or from the graph you can do it. Alright, perfect. So the velocity is positive, and I need you to remember that number because your justification is not complete if you just state that the velocity is positive. It's also important that you state how you know it's positive, and the way we're going to state that we know it's positive is because we actually have the value for the velocity. So make a note right now that for v of 4, it's equal to 2.978, or you could put 2.979. I'll just put 8 to truncate. Now, I also need to know what the acceleration is at 4 to figure out if they're the same signs or different signs. So remember, on your calculator to figure out acceleration, you're going to go to the home screen, you're going to go to Math 8 for numerical derivative, recall the y1 function, and input 4, and it will find the derivative evaluated at 4, which will be the acceleration at 4. On Desmos, I'm just going to put f prime of 4. And I get that a of 4, the derivative, is equal to negative 1.164. So I have those two numbers written down on my paper. Please make sure that you're writing them down on your paper as well, so that you have a record of what v of 4 is and what a of 4 is. So here's how we're going to go ahead and justify this. Your work, obviously you don't need to type in everything you typed into the calculator, you're just going to type in your answers. Your work is going to say v of 4 equals, and again, I don't want you to just put positive, I want you to actually write the number that it equals, 2.978. And then you're going to write a of 4 equals negative 1.164. And then you're going to conclude that therefore, the particle is slowing down at t equals 4. Because, you have to offer a because. You have to interpret your work. You can't lead them to interpret it. Because v of 4 and a of 4 are different signs. Alright, and that's how you get full credit for this type of question on the AP test. That's how you're going to get full credit for this type of question on one of my tests as well. So your work is showing that they're different signs because you actually calculated it, and your conclusion is saying that it slows down at t equals 4 because they're different signs. If you don't show the work, that's considered a bald answer. If you just put it slowing down, if you just show the work and put that it's slowing down without interpreting why it's slowing down, again, that's considered a bald answer. So please make sure that you show what v of 4 and a of 4 is, and then in addition to that, make a conclusion about what that means and why you know that it means that. Alright, for the next part, part B says, find all times t in the interval when the particle changes direction and justify your answer. So, remember that to find where a particle is changing direction, let me bring us back to my demonstration of what we were looking at in class when we first started learning about particle motion. So I'll try to draw it on my screen since you don't have me staying in front of you. So if you remember when we were in class, when we started learning about this, I was on an invisible number line. So here's me on an invisible number line. There's me. And we said that we were going to start walking. There's me walking. Sorry, my head takes a bit to catch up to me. I was going to start walking, and I started walking in these different directions. So I walked this way, and then all of a sudden I stopped. And then I walked this way, and then all of a sudden I stopped. And then I walked this way, and then all of a sudden I stopped. And I said I could keep going if I wanted to, but anytime that I stopped, it meant that I could change direction, or I could have just kept going in the same direction. And you have to kind of decide, or I'm going to teach you really quick how to figure out if I'm actually changing direction, or if I'm just stopped for a minute and then I keep going in that same direction. So, with that said, the first thing is to figure out where the velocity is equal to 0. All right, so we want to know where the velocity is equal to 0. That's the first job we have. Once we know where velocity is equal to 0, we're just going to check to make sure that it's actually changing sign. So, if you are going in the positive direction, that means your velocity is positive. As soon as I go back to the negative direction, that means that my velocity is negative. I'm moving to the left again. And going back to the positive direction means I'm moving to the right. So I'm looking for two things. Number one, I'm looking for where the velocity is equal to 0. And number two, I'm looking to see to make sure that it actually changes sign or goes from positive to negative or vice versa from negative to positive. If it just comes down and bounces, like touches the x-axis but then bounces back up again, that's not a change in direction. That would be a stop, but then a continuation in the same direction. So let's look at the graph really quick. We're going to, you guys already have this in your y1, so we're going to go ahead and graph that. Now I only care about x values from 0 to 3, so don't look at anything else besides these x values from 0 to 3. So change your viewing window from 0 to 3. And then for y values, honestly, you could go from -1 to 1, because I don't really care what's happening way above the graph, and I don't really care what's happening way down below. I only care if it's crossing the x-axis. So if I can see the x values from 0 to 3 and the y values from -1 to +1, that will give me a pretty clear indication on whether or not it's crossing or just bouncing at those points. So let's go over to Desmos, and you go on your graphing calculator, change your viewing window really quick while I look over here. So I'm going to change my viewing window. On Desmos it's done a little differently, but you guys know how to change it on yours. So I'm going to look at a viewing window from 0 to 3, and then again I told you guys to look from -1 to +1. So your graph probably looks something like this, especially if you listened to what I had to say about going from 0 to 3 and -1 to +1. And your step is even 1, so your graph probably looks like that. Now, if you want to zoom out, like if this feels uncomfortable to you, please go ahead and feel free to zoom out so you can see more of it. I still only care from 0 to 3 though, so please don't look over here at this x-intercept. Please don't look over here at this x-intercept. I'm only looking at the places where it crosses the x-axis in between 0 and 3. And if you look closely, it only does that one time. It only crosses right here, that one time. Right here is where I'm looking. Alright, so that is the x value that I'm concerned with. I need to know what x value that is. So, we've talked about how to do this before on your graphing calculator, but I'll explain one more time. One option is you could graph a second function. So underneath where you have y1 equaling this function, enter a second function for y2 of 0. And if you enter a function at 0, it's going to graph a horizontal line, a constant line right here at 0. And then you can use your calculator's intersect feature, and it will find that point of intersection for you. Or, if you don't feel as comfortable with that, then you can use your graphing calculator's function to find the 0. So remember, it would be, when you're looking at the graph, it would be by pushing second calc, and that's where intersect is as well. So you're either going to push second calc and then find intersect, which I believe is option 5. And it will find the intersection of the constant function at 0 with your function. Or if you're going to go the other route of finding the 0, then you're going to push second calc from the graph, and I think it's option 2 is 0. So you're going to push option 2, and it will ask you a couple questions. It says, what's the left bound? So choose a number less than this. Obviously, if you're estimating, this looks like it's close to like 2.75 maybe. So a number less than that would be 2, and then it wants you to choose a number to the right. A number greater than that could be 3, and then it wants you to guess. So I might guess 2.75 if you're finding that 0. Now Desmos is kind of a nice program because Desmos knows that we care a lot about those x-intercepts, and so it actually calculates it for me just by clicking on it. But you, on your graphing calculator, are going to have to do a little bit more work to find this point. But you should get 2.707. 2.707. Let me write that down so I don't forget. T equals 2.707. Alright, so we come back over here, and now it's time to justify. It says, find all times t in the interval when the particle changes direction and justify your answer. We're going to say, the particle changes direction, and I always want you guys to answer these questions with full, complete sentences. The particle changes direction at t equals, what did I say, 2.707. Because there is a 0 on the velocity graph meaning the particle is stopped. And the velocity function changes from positive values. If you remember the graph, I won't go back to it because it'll erase what I'm writing, but if you remember the graph, it went from above the graph to below. It went from above the x-axis to below the x-axis. So the velocity function changes from positive to negative values, meaning the particle switches from moving right to moving left. Now, I know that's a ton to write, and I have never personally gone to grade AP Calculus tests before, so I cannot guarantee that this is word for word exactly what you have to have in order to earn full credit, but I can guarantee that if you had this word for word, that you would earn full credit. Here's why. We answered the question, we gave them the time interval it happened, and we justified. Not only did we tell them what we were looking for on the actual graph, so we looked for a 0 and we looked for the fact that it changed from positive to negative. I think maybe that might be enough to get you full credit, but I know I am guaranteed to get full credit if I not only explain what I looked for on the graph, but in addition to that, I explain what it meant about the particle's motion. So the 0 on the graph indicated that the particle was stopped, and the fact that it changes from positive to negative indicated that it went from moving to the right to moving to the left. Again, I don't know if you need to offer that interpretation because I've never been to the grading conference before. However, if you have the time, I would offer those pieces of insight because it will help to prove to the reader that you know what you're talking about and earn you full credit. All right, next question. Okay, this is a new question. I don't remember what AP test this was from, but it is from a previously released AP test. It says a particle moves along a straight line for t less than 0, greater than 0, less than 5. The velocity of the particle is given by that new function, and the position of the particle is given by s of t. It says it is known that s of 0 equals 10. Again, just like the last problem, this is going to become helpful in later parts of the problem, but we don't know what it's there for yet because we have not talked about integrals, so don't worry about that piece of information yet. So it gives us this function for velocity. I'm going to give you guys a minute. I want you to type that in for y1 while I type it into Desmos. All right. I'm going to try to remember to put x's instead of t's this time. Negative 2 plus x squared. Negative 2 plus x squared plus 3x plus 3x all to the power of 6/5. Notice, by the way, that this is in the calculator section. You would not want to mess with this function if you didn't have a calculator. Minus x cubed. Minus x cubed. All right, beautiful. Now again, I am given some specific t values to look at from 0 to 5. So I'm going to change my viewing window on the t-axis from 0 to 5. And then I'm going to go ahead and make sure that I can see everything on the y-axis. So let's see what's a good viewing window when I do that. So I'm going to change my x-axis from 0 to 5. Oops, 0 to 5. There we go. And then I can't really see everything that's happening up top or down below. So I'm going to change it. Instead of negative 1.974, I'm going to go down to negative 10. And then I'm going to go up to positive 10. Let's see what I can see there. All right. So I can see a little bit more. And let's see what happens when I do that. Okay, that's probably more likely what you see on your graph. I still can't really see everything that's happening below, so I might even go down to negative 20 just to get a better indication. I think that's pretty good. It's okay that it kind of gets cut off down here. I don't think that's super, super necessary for us to be able to understand this graph. Alright, so here's what the graph looks like. Negative 2, let me just verify one more time to make sure I have it typed in correctly. Negative 2 plus, t squared plus 3x, t squared plus 3x, or 3t. To the power of 6/5 to the power of 6/5 minus... Okay, perfect. I have it typed in correctly. So let's see what that question's asking us. It says find all values of t in the interval for which the speed of the particle is 2. The speed of the particle is 2. Now this is the velocity function, all right? This is the velocity function. I hope you remember. Remember that the speed, I'll say that one more time. Remember that the speed is the absolute value of velocity. There's a couple ways you can look at approaching this problem. The way that I would probably approach this problem is I would graph a line at 2. I would say y equals 2. So on your graphing calculator, you would actually type in the function 2 for y2. So you already have this function typed in for y1. I would type in the function 2 for y2. And you can see, just by looking at that it's going to intersect twice. I see it intersecting twice, and you can just use the intersect feature on your calculator to find those points of intersection. Now, you have to be careful because this line is where velocity equals 2, but the question's asking for where the speed is equal to 2. So not only do you have to look at where y is equal to positive 2, but we also need to look at where y is equal to negative 2. So let me change this one so you guys can see the colors. So I also care where it intersects down here at negative 2. And I can see that I have another point right here. So I have this point, I have this point, I have this point, and then I don't know if that's a point. It kind of does look like it though. Yep, I have that point too. So I have 1, 2, 3, 4. There are 4 points in this interval where the speed is equal to 2 because there are 2 above the x-axis at positive 2, and there are 2 more points down here below the x-axis at negative 2. All 4 of those points would have a speed of 2. So again, to find these 4 points, this one, this one, this one, and this one, it would be your responsibility to find the intersect feature. So you'd have to do it 4 times, but you would go through on your calculator, and you would go from the graph, you would go second calc, intersect, which is option 5, and go first curve, second curve, and then take a guess at what each of these points would be. So you know that this one's a little bit less than 1, so maybe 0.9, type that in. You know this one's a little bit greater than 3, so 3.1, type that in. This one's about halfway, so 3.5, type it in. This one looks like it's at 0, so type in 0, etc., etc. So that would take a little bit of time on your graphing calculator. I know it takes more time than it does here on Desmos. But that's how you would go through and find these 4 points of intersection. So I'm just going to write them down really quick so that we can put them in our justification. T equals 0, 0.944, 3.128, and 3.473. Alright. By the way, I did say there were 2 ways to do this. The other way you could do this, if you really wanted to, is if you wanted to actually graph the absolute value of this function. So if I graph the absolute value of x, it looks like this. Alright, so this is the absolute value. So here's the original function one more time. Notice that there's these pieces that are negative. So here's this piece that's below the x-axis. Here's this piece that's below the x-axis. If I graph the absolute value, it just takes those pieces and reflects them above the x-axis. So same thing here, reflects it above. It doesn't take the positive pieces to reflect down. It only takes the negative pieces to reflect up. So that's what the absolute value graph of velocity looks like, and this is the speed graph. So now if I look for where that equals to, you can see that there's still 4 points, and they're the same 4 points that it equals 2 at. And so these are the points that you were calculating. So you could do it either way. You could either look on the velocity graph for where it equals positive or negative 2, but you can also look here on the speed graph, which is the absolute value, and see that there are 4 points as well. So if I come back over here, alright, find all values of t in the interval for which the speed of the particle is 2. We're going to say the speed is 2 at t equals 0, 0.944, 3.128, and 3.473. Alright, and again, notice that we rounded to 3 decimal places for every single one of these. You need to have 3 decimal places for your answer in order to get full credit. And then maybe just adding one more thing. You don't necessarily need to put a sketch of the graph. Oh my gosh, we did it wrong. I didn't even read that. Look at me. I was reading up here between 0 and 5. I didn't even read the problem. It said find the values in the interval from 2 to 4. So if we look closely at this one more time, I hope that it's clear to you that we can eliminate 2 of them. So goodbye to these. Those are not between 2 and 4. So that's what I'm looking at, between 2 and 4. So this number is in between 2 and 4, and this number is in between 2 and 4. So the speed is 2 at t equals 3.128 and 3.473. If you caught on to that earlier, great. You're probably shouting at me through your computer right now. But at least I caught on to it before we finished the problem. By the way, that brings me to a good side note. On the AP test, if you make a mistake, you do not need to spend time erasing it. You can just cross it off. So if you accidentally put all those and then came back and read this again, you were like, oh no, I didn't need these. They're wrong. Don't erase them, because I know it doesn't seem like erasing takes a long time, but it can, depending on how much of a mistake you made. Instead, just cross them off. Whatever's crossed off, the reader will not grade. So the speed is 2 at t equals 3.128 and 3.473. And I would just add in one little extra explanation about how I know that. I would say this is because velocity is equal to 2 and negative 2 at these points. Alright, and I think that's, again, I can't guarantee you would need that second part. I think figuring out that these actual values, 3.128 and 3.473, those are pretty accurate values. So I'm pretty sure the reader would know that you knew what you were talking about. But again, if we have time, it's always nice to offer as much explanation as possible to kind of hit home on the fact that you really do know what you're talking about. Now, we're not actually done with this section. There are 2 problems left in this section, but we already have a 25-minute video. So I'm going to go ahead and put a stop to this, and then I'll record the last 2 problems in a separate video.